Hello Natroners and welcome back to another episode of VFX with Natron. So, today, I kind of went in a different direction. I was originally at one point over the past week, I was thinking about doing some stuff. And then, things got wonky and it always does, doesn't it? Anyway, today we're going to be exploring Python, or at least an aspect of Python, inside of Natron, the expression system, in a way that I don't think a lot of people realize just how powerful and how much control an actual individual node expression actually has over the entire program. We're not just talking about a node, we're talking about what a node can do with its expressions. And so there's no real, because of where this is going, and this is sort of open, free flow, and there's no real goal today, although I do have an idea for an inkling for something that some people might be interested in if they want to do some powerful stuff. But anyway, let's hop over into Natron and just start off with a, oh, I don't have this set up right. I forgot to start a few things. Let's get this going. And let's get this going. And let's resize more Natron for you guys. Alright, so there we go. Alright, so we're in Natron. And the first thing we're going to do is we're going to obviously, well, my favorite node to explore expressions is the text node. So we're going to put a text node in here. And we'll just make sure it's hooked up. And the reason I like the text node is because we can get feedback directly to the screen, even though we can technically do that in other ways as well. But the thing that I want to do with expressions right now is we're going to just right click on the text field, and we're going to just go straight into setting an expression. And we're going to look at the dialog here, and we'll notice, we've seen this at billions of times. Whenever we hop in and start writing an expression, we see this up here. And I don't know how many people have actually read this and seen that it says up here, also the following variables have been declared. This node is the current node. Okay, that's an interesting one that we've used that in the past. This group, when this node belongs to a group, it references the parent group node. Otherwise, it will reference the current application instance. That right there is really, really interesting, and that's the thing that we're going to be exploring a little bit today, more so than any of the other stuff. So then it says this parameter is the current parameter being edited, and then you got the dimensions, which will, if you're doing a multi-dimensional thing, you can tell it so you can have the same expression apply to multiple dimensions automatically. In the case of like an XY where you want them both to translate in a diagonal, it's the same. Anyway, then you got frame, which we've also done. But it's this group. What does that mean? And this node, what does that mean? Natron, I probably should have preset this. I should have pulled up Natron, the actual website with the Natron documentation, but we're not going to do that. We're going to just sort of wing it, and if I forget something, oh well. So the thing we need to do first of all, what is this node? I mean, what is a node? What is it? It's Python. Almost all of Python is excuse me, not all of Python. All of Natron is integrated via Python. There's tons and tons and tons of control you can have using Python. So, for example, if we, one of the things we can do is, if we type in str for declaring something as a string, because what I want to do is look at the actual what this node actually is. So if we put str, that translates whatever we are into a string, and that will be able to go into our text node, and we'll see it read out here down in the results. Most other nodes that are not text-based will throw an error if you try to feed it text, or give you, no response or anything like that. But text, as long as we're doing it inside of a string, we can basically call numbers, we can call text, we can call whatever, and we can force it into being something that gives us a result, which is why I like the text node. So if we just type in this node, capital node, like so, we can see it gives us this feedback right here. It says Natron engine dot effect object at, and then it gives us a memory address. All right. Well, that's really interesting. That's really useful. That means that that this effect, this text node, this is where it exists inside of Natron. Natron knows it by this information. All right. This also raises a question about what is this group. All right. And when we type in this group, we see that it says Natron GUI.GuiApp object at, and then it gives us an address. I don't know if people know what that actually means and why this is kind of exciting. So a group, if you don't know, Natron itself, every version of Natron has to start off with this concept of the root of a base like package where something exists, and that in groups are basically a self-contained scope. Okay, what scope mean? We've sort of talked about that before. It means that the things inside of a group are self-contained. If you make a group inside of for example, here, let's just for the moment just close this, and because it doesn't matter that that's there. If I just create a group over here, oops, that's not going to be a group. I think it's Control G. I thought it was Control. Oh, you know what? Let's just make. Where's group? Oh boy. I thought it was, maybe it was Alt G. No, Control G. Shift G. There it is. No, it's not Shift G. All right, maybe you have to actually have something. Oh well, text. Let's make another text node. Oops, text node. We're going to just throw the text node into. We're going to hit Control G, I believe. That's weird. I could swear. Do I have something? I thought it was, you select it, Control G. There we go. I had to select it. That's what I wasn't doing right, but whatever. Anyway, so when we make a group, we have it has an input. This is basically the input coming in from the scope. We can see this is a group tab, and out here we have this group with our text node inside of it. Okay, here's our text node that we put inside the group, and this is an input that comes into the group, the source, and then this is the output, which outputs back to our higher up level or outside of it. But this text node in here cannot talk directly to this text node out here. It has to, in order for this text node to talk out to this other text node that's outside of the group, it actually has to go through the group itself. We actually have to create information inside of this group that talks to the subcomponents, and then this group actually does the communication with the bits outside of it. And that's how it works, because otherwise the problem is if we had a text1 inside of the group, we would have a naming conflict. We would have a text1 in here, and we would have a text1 out here. Actually, let's do that. We may be able to actually create this. Natron might be too smart for this, but if we just make, for example, color bars here, and then we go over here and we also type in color bars here. So this says color bars 1. And this, we can see we have both of these nodes are up, and they're both called exactly the same thing. And this creates a problem because they're in two different locations. One is inside of a group, and the other one's inside of our base project. And this would create, if they said both existed inside of the base project, then Natron wouldn't know which node is which, but at least not by name. But we don't have to worry about that because they're in different scopes. This is isolated from the other. All right, and the only way this can communicate is if we take a property on this particular one and we link it up again to some control on the group itself. All right, but this is useful for, why is this important to know? All right, let's take a look at this again. We have this thing here, and on our group node graph, or I should say on our node graph, not in our group. In our node graph, when we did call this group, it says we're looking at a GuiApp. Whereas if we go into this group and we also pull up the text node here, and we basically set an expression on this one, and we say this, or str, excuse me, yeah, str, parenthesis, this group, all right, we can see that it's an effect object, all right? So this is very, very different. An effect object is self-contained. It's a sub thing. It doesn't talk to the program in a bigger sense of the world. But this one out here does. This one has way, way, way more power. And this actually creates some interesting things that we can do, especially with regards to group nodes, because group nodes can be exported, and this means we could make a group node that is a plugin that when we load the plugin can gain access to system level stuff, or to not system level, but yeah, well, not system, but Natron level stuff, base root stuff, core program stuff. And you're saying to yourself, what are you talking about? What do you mean we can do stuff at the base? Well, all right, let's go into this expression, for example, and let's look at what we can do here. Okay, most people may know that if we type in this group, all right, and we do, you might know, one of the things we may want to know is, well, what do we have for nodes in our composition? How many nodes? We have 3 nodes here, right? So if I type it here and I say, let's see, I believe it's called getChildren. And we do this, all right, we don't see anything. Well, that's because I got rid of our str, parenthesis, thisNode, getChildren. And there we go. We have a whole bunch of children here. We can see that we have an effect object, we have an effect object, we have an effect object, we have all effect objects, in fact. It's a list of effect objects, but they don't tell us what those effect objects are. So it's not really useful in this sense. Well, maybe we can find this particular node in this group of things. That's all the nodes that exist in basically this node graph right here. We have 1, 2, 3, 4, oh, it says 5. Okay, well, maybe there's a 5th one somewhere. It's probably the stuff inside of the subgroup. I don't know. Anyway, I have no idea what these are at this point, because I can't tell from these names. I need something that's human readable. So I've switched this so that it's multi-line, and I'm going to just change it so that instead of this node or this group being assigned here, what we're going to do is do something a little more, because we know that this group at this level that we're working at, I believe, I just want to make sure, yes, we're outside of the group. We know that this group is refers to the application, or to the GuiApp. So that means that I'm going to just say for the GUI, all right, so people understand there are 3 things. There's group access, which means that you can access things inside of a group. And if you're in a group, that means you're stuck just accessing the level of the group. The GuiApp is this. This is what we're seeing here on the screen is the GuiApp. But GuiApp inherits the application. And you say to yourself, what do you mean it inherits the application? Well, it means, all right, let me try and change this. I'm going to just put in this app equals that, all right? And by that way, it's sort of, we're saying that, oh, actually, I don't want it to be that. I want this app to equal this group, all right? Just so that we kind of are thinking of it as what this is. This application is equivalent to this group when we're at the project level. All right. So anything I want to do with this app, I can do by typing in, or I could technically do it by typing in this group, but for clarity's sake, we're going to use this app. All right. This app, what do I want to do? Well, I want to, first of all, I want to know, all right. I'm just thinking about this. I want to get a list. I want to make a list of the nodes in this group. All right. So I want to say, I'm going to make a list. We'll call it list. That's actually really bad. That's so generic. There's potential issues using list. We're going to just do, we're going to call, LST. List is equal to, this group, because we're still doing this group, and we said get children, and then we're going to do this. All right, so there's our children. All right, and and it's returning it because it's actually throwing an error, and we're not seeing the error because we have it's basically using what the last known good output was, which is, well, actually, which was apparently the list that we had made, even though this is technically not doing it, because we got to give it a return equals stir, and then we'll go, for right now, we'll go LST, which should result in basically the same thing. All right, so what I want to know is if this node, all right, this, I want to know if this node, which whoops, off typo, that should be capital. I want to know if this node is in the list. That will tell me if it's in the list. I want to make a variable. I'm going to make something called out. Make it out equals false. FALSE. We're going to say out equals false for right now. If it is in the list, we're going to make it out will equal true. All right. All right. So I want to know return out. So it's telling us right now that according to this node, the current node we're looking at, isn't in that list that we printed, that was the entire list of all the nodes that we saw in this group. So this creates this question, well, wait a minute, it has to be because it's right there. It's right here. We know it's there. So why are we not seeing it in the list? And the reason is because they're two different instances of the exact same thing. They're not actually being referred to by Natron inside of this as the same thing. We have to actually use the node name to figure this out. So what we really want to do, and this is the reason we made a list, what I want to do here is we've made a list of all the children, all these, and we're going to say for each node in the list. Actually, you know what we're going to do? We're going to actually change that. I think we're going to call it nodes instead. And we're going to say nodes here, and we're going to say nodes for right now. Nodes. All right. All right. For node and nodes. So for each node in the list of nodes, what we want to do is say if I want to hit tab one time. Okay, didn't mean to hit capital, by the way. If this node is in, we want to say if it equals the node, the current node, then we want it to output true. We're still getting false. Okay, and the reason is because we're still looking through the same things. We still are looking at it based off of the node memory location, or what it's referring to itself versus Natron or the application. Again, application is looking at one scope, the node itself is looking at itself. Only it's contained inside of itself. So what we need to do is refer to it by the label, okay? Because the label is what the name of it is. So if we go getLabel, parenthesis like that, okay? We're going to be getting the label of this node, which is going to be text1. And then I'm going to say for the node, for each node, it's going to compare it. It's going to see if this label is equivalent to the label of any of the nodes in the thing. And as soon as we change it to that, we can see that our result has changed. Now we are getting a true. So what we're doing is we're basically looking at this and we're saying, okay, is there a text1 inside of, is this node called text1? The answer is yes. Is there a node in that list of nodes that has the name text1? And the answer is yes. So we know that when it gets to that point, that that we can do something to this. We can, for right now, what we're doing is we're telling it that we want to switch it from the output from false to true. And we can see that the output is indeed coming back as true at that point. So this means that there's a lot of things. This means we can access this node, but it also means we can technically access other nodes. Well, okay. This isn't really all that great from the standpoint of it means we have complete access to finding nodes, but and that we know that this node can find itself in the list. It knows that it's there, but that's not really that useful. Let's see, what else could we do? Once we're on this node, once we've found that we're at this node, I'm going to change this so that instead of out being false, we're going to call let's see, I'm just trying to think of tn for this node equals false. I'm just putting tn for it because I want to make this a internal variable instead. So I'm going to say change it so that now tn is the thing, and then we're also going to just say we need to initialize out equals that, and then what we're going to do that way outputs. And here what we're going to do is we're going to just say after we've done our for next, we're going to say out equals tn. Hopefully, if everything worked correctly, it will result in the exact same thing. So the reason we're doing this is because I don't want to constantly change out. I want to keep my output, isolated from things I'm doing inside of here, unless I want to actually do it. I want tn to be something that it only fires when, or only this statement I only want to execute when we're on the correct node, because I only want to be accessing this node using, I'm thinking of this from an application standpoint. This way, this node, I could take the script and put it into any node. Well, in theory, I could put it, and I could define a node. In other words, here we're saying for node in nodes, we're testing the label against the node label. Well, I could say if the node label, if I just say, hey, let's instead of no, let's try this node. If node get label equals this node. We said this node, right? Node. This is basically the same thing, but there's a crucial difference. Where we're testing the nodes first. We're comparing this node versus this here. And it just, the way I like to think of it is that now, instead of this, we could just put a string in here. We could just say, color bars. So let's see if I say color bars 1, we can see that it turns true again. So I can access color bars through this. So I can create any node I want from this, if I wanted to, inside of this. So this means I can not only can I access I can set it up. What I'm doing is I'm saying anytime I'm running to color bars, it is basically going to it's going to execute this whatever comes after this if statement, or in this if control, this comment. So I'm going to move this down, tab this over so that it's over like this, so that we're actually working in it. All right. So then we can sit here and say, okay, well, we've created this situation where tn is true. Well, I only want this to fire if tn is equal to true. So if I can say, okay, well, or this situation. So we're here, we're saying this is true. I want to create another situation. I want to prevent this from firing multiple times. Why do I want this to be prevent this from firing multiple times? Because if I don't control this, what will happen is every time this frame, the Natron advances a frame, this script will run, and this script will fire. So if I did something like, for example, at an app level, like, for example, creating a node, which we can do, okay, well, this is where we're going with this. If we create a node with this, an application node inside of a node, it will create, every time it changes frames or every time the program refreshes, it will attempt to create a new node. And if I say make a new text node, for example, it would create a new text node for every single frame that for every single frame that passed, and it would try to do it multiple times every time the program refreshed. So just stopping this would cause it to refresh at least once, if not probably half a dozen times. So we would end up creating like 7 nodes, which is not something you really want to have happen, because what would happen is we would, as soon as we hit the play button, it would basically fill up Natron, fill up our project with a bunch of nodes, which would be terrible. That would be horrible. But we could theoretically do this. This is why I say this is dangerous programming, what we're doing here. But I want to show that we can actually create a node. But I want to prevent Natron from creating billions of nodes. So what we need to do is control this. All right. So we understand why I'm getting into where we are. All right. So I'm thinking about this. I haven't really planned this too far ahead. I do know we can do this. So the next thing we need to do is we actually need to get an ID. We need to, all right, first of all, we need to create a variable that says that this can only fire one time. All right. How can I guarantee that this will only fire once when I do it? The problem we've run into is if I create a thing here on this, and I'm just thinking about this. If I create an expression here that or a variable here, every time this cycles through, which happens every refresh of the application, it will attempt to run whatever I do. So I can't put a variable here. This means I need to create a variable someplace outside of this that will only happen or can only be changed once. Now, in the past, what we've done is we've created separate nodes that are sort of like controller nodes. This is what we did with SE, XPR, things like that, or with Shader Toy. We sort of put the scripts and stuff, common stuff, and out in an extra node off in the middle of nowhere. And in fact, we did this sort of with smart nodes. But the problem is that means it's not contained within this node. That sort of defeats it. It means we're using 2 nodes to deal with something that it removes the ability to sort of make this super node, so to speak, that has something that can be controlled. So what we really want to do is create a user property. So what I think we want to do here is I think we want to hit OK for right now. And we're going to go up on this, we're going to go on to our text node. Now, mind you, when we ultimately do this, we're going to actually be we're going to apply this to a group node. So maybe, because we can't, I guess we need to talk about this as well. If the goal of this is to make this into something that we can load in to be like the super plugin or super node that does something, that gives us, that defines something whenever we load it for our programs sort of, or for our application to have access to, we need to make it so that that node can be exported as a plugin. Well, we can't export an individual node. There's no way up here to export this as a plugin. But for group here, we can see that there's this option to export as a PyPlug. Now, I haven't tested this fully yet, so we're going to try something here. We're going to do a couple things. We're going to create some user parameters onto this group node right here. We're going to create a new. We're going to click on add, which is going to add a thing. It's going to say we need something, and we're going to just call it, you know, we talked about smart nodes in the past. This is kind of along the lines of making nodes smarter, or making them, you know, so I think we're going to call this, just create this, and we're going to call it a smart tab. All right, this is just going to be called smart, and we're going to call it, well, we'll call it smart node. Not because this is necessarily the same type of smart node that we was talking about way back in the beginning, where I sort of hard. Oh, I held off. We're going to call the thing smart node, because this is actually, we could use this for that, because this is actually, we could expand this to do smart node stuff, which is why this could be a useful thing. All right, so we'll call it smart node because we're about making this smarter. And what we want to do is, I want to create two text inputs. I want to create a text input that I'm going to call feedback. Actually, first I'm going to call it code. I'm going to call it code. So let's call it, no, we'll just stick with the code. And we'll also call this code. All right. And we want the code to be multi-line, so that we can just keep it like that. And then we want to add another one, and we're going to call this smart, or we're going to call this feedback. Feedback, maybe? Feedback. And we'll call this feedback. This is kind of like a status line and so forth. Okay. And let's see. And I think I want to do... So, all right, let me explain. We might even, for the moment, I'm going to just add one more thing, and that's going to be, we're just going to do an integer. This might bite us in the butt, because the problem is that, see how we have, the integers have a maximum amount of cycles that they can do? They have minimums and maximums, and I think these are absolute. These can only go up this high. And the problem is that once you hit that point, once we get to the maximum, this could be limited. Whereas with the text node, I believe if we put it as a variable inside of the text node, you know what? I think just for the safety of this whole thing, I'm going to make another text input. I'm going to not make it a multi-line. But it means we have to transform it from text. I don't know. This is just me maybe overthinking things. I'm just going to call it a variable. Variable. Well, and we'll call variable. Well, what's this variable going to be? You know what? I don't think variable is a good name. It's not very descriptive. It's millions of variables. What do we want this to do? What is my goal? My goal is I'm going to call this loop lock. All right, this is going to, yeah, that's what I'm thinking. So I'm going to call it loop lock, and I'm going to give this a number, actually. And I want that to be capitalized, loop lock 1. There we go. And then we're going to call it loop. Just making sure lock. Loop, and we'll call it loop lock. And I'm just going to keep it there. And we're going to keep it one line just for right now. So, all right. So we've created this. We're going to close it. We're going to look over here, and we have this thing called loop lock. And why do I only see... Uh-oh. Oh, fudge. I made... Oh, feedback. Oh, bother. Well, we're going to delete that node because that's a use. Oh man, I might have to restart. So here's a problem with Natron. A lot of times with if you declare a variable inside of a group, Natron will initialize it, and then it sometimes won't let you change the property name afterwards. And I don't want to lose that property name for the group. So we're going to create not a transform. We're going to create a text node tab text. Sorry, that was a bad one. We're going to group it. So Control G to group that text node. We're going to go back out to the main thing. We're going to not worry about the fact that it's called group 2. We're going to go into the group 2 settings here. I'm going to close this. I'm going to minimize this or reduce this down to 1 input. We're going to go and we're going to manage user parameters. We're going to add, we need to create smart node. And we're going to call it again smart node. And we're going to change that, make sure we set that to a text input. It's going to be multi-line. We're going to call this again, we're going to call this code. And we're not really going to be doing, we're going to actually be doing, well, doesn't matter. We're going to just say here, just make sure we set this to text input. We're going to set this to feedback. I want this to be feedback. And I want this to also be multi-line. And then I want to do one more. It's going to be text input. And we're going to call this, this is going to be loop block. Loop block 1. Just in case I make another one. I don't know if this is going to be then. Loop block. So, and this is not going to be multi-input. So, all right, there we go. All right, that should work. Go over here. Good. We have 3 things. We have our code, we have our feedback, we have our loop block. Now, people can play with this, do whatever they want. But why are we doing this? Why are we making it? Well, by separating these things, what it will do is we can create variables elsewhere. We could use we can have it put our feedback directly down here. That way our code isn't our actual feedback, and our feedback, this creates some really interesting advantages. Let me show you one of the advantages of doing our code this way. So we're going to put our expression here. Actually, before we do, let's go over back to our text node. Let's go in here. Let's edit this expression. Let's select all of this, copy it. I want to make sure I'm copying it. Okay. And then I'm going to go over here and I'm going to go in here and set my expression here, and I'm going to paste this back in here. So it's saying we have our first problem is that we have an unexpected new line. That's because we didn't make it multi-line. There we go. We say it's coming back true. But instead of returning here, I don't want to return the string. All I want to do here for return is I want to return something constantly. I want to make this the output here. Whoops, I didn't want to do shift return. I want to hit return. I want to do return equals, and we're just going to go, just give it quotes. So it doesn't return anything. What instead I'm going to do here is for feedback, I'm going to hold down the control key and grab hold of this feedback area. I'm going to just drag this in here, and you can see that it says group 2 feedback get. All right, so I'm going to copy that. All right, I'm selecting it, copying it, and I'm going to put that here, paste here. Okay, that way we can get rid of it down below. This is a little hard to see with the text over it. And you're wondering to yourself, why are we doing that? Well, actually, what we're going to do is we're not going to do this. We're going to set this here. Instead of group 2 feedback, what we're going to do is set it to so that instead of saying group 2, we're going to say this node. All right. Whoops, not this node to this node. All right. Why are we doing this? The reason we're saying this node is because I want this. If I export this as a plugin, I want it, any node that loads it in, I want it to always do this. I want for this node, anytime it calls up this node, I want this to run. I want our output to go to this and feed whatever's coming out of this to our feedback line. I want it to go there. So instead of get, I want to change this set. Okay. And what am I going to set it to? Well, I'm going to set it to out, I believe. I think this works. Set. Set is so blah, 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 blah. All right. I think it maybe I'll need to do set. Oh, wait a minute. I didn't do that right. I wanted to say set out. Excuse me. Set out. Did I do that? Well, not P out. Out. Boy, let's pull this over. Get that out. There we go. Is that right? T and this feedback set out. Oh, because out is not a string, we have to first convert it, cast it as a string. So str present parenthesis out. There we go. And so now, there we go. We have our feedback is now, we're setting it out to here, even though our code is being handled by a different aspect of it. So why is that useful? Let's look at this from a standpoint of you are making a node that you don't want people to fuck with. You don't want people to mess around with, all right? I want this code to not be accessible in the future. All I have to do to make it not accessible is I just have to go over here, select my code, edit the code, and click on this option here that says hide. Once I do that, close there, and we go back to our smart node, and you'll notice that we no longer can edit the code, but the code is still functioning. We still are getting true, and no matter what I do, if I click on there, this may not actually, I don't know if it's actually going to update properly. It's not going to update in this situation. Oh, there it goes. It did update. See, the next time it actually refreshed, it actually put the feedback or fixed it. It put what we wanted back into this feedback. All right. Even though this is a text node and we could technically modify this. This is updating this in real time or whenever the program properly refreshes. And there's ways we can force it to refresh on every frame, but we're not doing it. This is, again, looking into things we can do that are more complex, potentially dangerous here. All right. So let's go back to that and let's go back to our code because we want to edit our code and unhide this so that we can still edit it. And notice that when we do that, it did something weird here, which is it switched back to the node property. And the reason it's switching back is whenever you update this, it always goes to the first or the topmost input on a given node. Goes to the first tab, and in this case that would be node because it's not. So what I'm going to do is just move this up so that it always, our smart node settings are at the very beginning for right now. And now let's see if that changes things. If we go edit and we hide this and hit OK, there we go. We can see it hid, and then we go edit and we unhide it, and there we go. All right, that way we're not constantly having to shift our tabs around when we want to edit our code. We can always shift this position if we want to put this somewhere off to the right, so it's sort of hidden from immediate display from a given user. And I want to keep an eye on the time. So this is all, we're sort of going around the bush. First thing, we need to do one thing here that I have not tested yet, which is I need to know, is this group, when we are accessing this group, are we still, or is this group or this app still the actual application instance? Let's find out. All we have to do, we've declared it up here that this is this app. We type in this app, and this app, it has a result of, aha, there we go. And it's saying this app is still, we're getting our feedback. It's saying that it is indeed a GUI app, a GUI application. All right. So now we're getting feedback. Basically, this is the equivalent. We've turned our group node into the equivalent of a text node in a sense. It isn't updating here, but we're getting our feedback in a sense. So we don't have to worry about it. It's the same basic principle as updating it over here, except for now we have our own sort of command line feedback that we can see where our code is going to, as long as we don't cover this up. All right, so Cool. This is great. This is exactly what we want. We want to put this back to out, or to out, so it's true. So now we want to do a loop lock. We want to get this loop lock. We want to put something into this loop lock, and so that the loop lock will, when it's one thing, it will start off. So what we need to do is set it so that we want to manually set this. Okay, so I'm going to say that this loop lock is equal to 0. All right, it doesn't matter that it's text or number. I'm just putting a 0 in there because it's an easy thing. It's easy. People a lot of times think of booleans and things as in integers in the sense of zeros and ones. It's easy. It's a 0. We can easily change this to 0 anytime we want. So now what I can do is I can sit here and I can say, now this is something we also have to remember, is anytime we drag a control drag, I'm going to hold down control again. And you can see that now whenever I hold down control, I get the little link. It looks like, I always think it looks like a C in a sense, but that's actually a link. There's actually two things there. It's supposed to be a silver. It looks to me like a C because the black link is really just too dark in my opinion. Anyway, it looks like something. Anyway, that indicates that we're actually holding down the modifier key of control. All right, but I like to think of that as C means that we're holding down control, so you can tell that my cursor's changed. I'm holding down control, and when I hold over this loop link here and drag this, it's always going to put the link at the end of our expression. So I'm dragging it in, and it puts it at here, and it's saying get. All right. So right here, what I'm going to do is I'm going to say this node. I'm going to change it from so that it references this node specifically, this node. So I know that it's always this node. All right, I'm going to select that text. I'm going to hit Control X to cut it because I don't want it anymore. We're going to back up one, and I'm going to go up here back to the where it says TN. We're going to change TN is going to equal that. All right. Okay, so it's going to get that. So TN is equal to that. So now we want TN. If TN, for right now, we're going to say if TN equals that, we're going to say that TN here is going to be changed to 1. All right. So right here, we can see that TN, because just so we're aware of what's going on, TN starts off down here as 0. When we get up here, we're telling it that TN is equal to 1. All right. Well, that doesn't do us any good. That doesn't actually lock us. That actually we're still back in the same problem. What we really want to do is we want to say TN equals 1 here. But what we really want to do is test it. We want it so that every time this node, this loops around and we get to color bars, we sense color bars, we want to test. We want to say if TN equals 0, then do whatever. Well, the problem is then we're going to just say, it's not one. Sorry. If TN equal, and that's really poorly written. I did that totally wrong. We want to say if TN equals, sorry, that was really bad. I was writing it in BASIC. Whoa, that's terrible. Terrible. Bad. All right. If TN equals 0, we want TN to do something. And what we don't want TN to do is we don't want to actually change it here. What we want to do is we want it to update this here. We never want to change TN in here. We want TN to only get here from inside of this, because TN is going to get this. So we're saying TN is grabbing it from here. Okay, then it's testing it. All right, it's been set. If tn equals, oh, we don't want it to be 0. Wait a minute. We want to say if it equals quote 0. We want it to be text, actually. Compare it to text. We can actually do it as actual text. Let's see, is that going to make a difference? It doesn't actually really make much of a difference. All right, if tn, if the text of tn equals 0, then we're going to just say, we're going to say out, for right now, we're going to put a hashtag here so that doesn't happen there. We're going to just say out equals true. True. Right? Or out equals, no, we're going to say out equals, it doesn't matter. We'll say out equals, no, true. True. Okay. So, is that working? Yes. We can see, let's see, out, we'll say out equals false. If a, it doesn't really matter that we're doing it this way. What we're doing is we're sending it as text versus. So we can see that this is doing it. But the question is this only doing it once? Okay. How can we get it so that we test this so that it count to see that it only does it one time out of all the times that it could possibly do this? All right. Well, that means we need to count. We need to make something that actually counts. All right. Let's see. How can we make something that counts? That means we need a variable that doesn't reinitialize again. So let's hit OK. Let's create a thing here. Let me think about this. What we're going to do is use a parameter. We're going to just make a smart node thing. We're going to add a new parameter. We're going to make it an integer. We're going to call it count. Counter. All right. So we're going to call it, oh no, that's bad. We don't want small letters, not on the script name. We want to call it a counter. All right. And it's going to be an integer, and we're going to set its default value to 0. All right. And that's fine. All right. So close. Yeah, good. All right. Edit expression. We're going to say, I'm just thinking about it. We want to, I'm just thinking, how is this worthwhile? I may be overthinking this, or maybe doing too much here. Again, this is freehand, not planned. I'm trying to lock it. I want to create one node. I want to make sure we're not counting. I want to make sure that this only happens once. You know what? Forget it. For right now, actually, let's just do CNT. CNT equals 0. All right, we've created a thing called CNT. All right. If TN equals 0, then out is, then we're going to say, all right, CNT, CNT equals CNT plus 1. All right. Excuse me. Got a hair in my mouth. Ugh. That was not good. All right. So let's see. Is this actually doing anything? So let's say CNT out equals CNT. Let's do, is out gonna equal that? Is that okay? Return equals that. Oh yes, here we go. That says it only equals 1. So it's only doing this one time. Did that work? Is it only going to do it once? It looks like it's only doing it once. Why is it only doing it once? Oh, because it's... I don't believe it. I don't believe it. Don't believe it. This is it only going to ever do that once? It says 0. No, it's counting to 1 one time because it's initializing. Okay. No, we need to edit this expression. I got to think about this. We're not actually increasing this. We need something that's going to constantly update so that we can see feedback. Because we're initializing it in this to 0 every time, every loop. So it says that count can't equal count plus 1 because count doesn't have a thing. All right. What we want to do, right, we need to here CNT equals counter. Let's grab, where was the counter? Let's grab that counter. Bam. We're going to do the counter get. I know us. Say this node.counter get. All right, so we're still going to have the same exact problem, is that it's going to, every time it's going to get the counter because the counter is not going up. Okay, so here we've done counter equals that. Then we're going to do here, we're going to just take this. After we've incremented it, we're going to say here, we're going to say this node counter set, oops, set like that. This node counter set CNT. All right, let's see if that works. There we go. It counted up to 6. We saw that. We can see it there. We can see the feedback. So it did it 6 times before it stopped. So we can see that Natron did basically 7 loops because it's at 6. That means it looped 7 times before Natron said, whoa, this is going to be an infinite loop. And we didn't want that to happen. So there we go. And the problem that and we can see it's counted again. It counted up to 8. And so if we go back here and we rewind it and we play it again, it counted again. And every time we rewind it, it's just constantly going to count up, because every time counter changes, every time we start the program, we've created a situation where let me explain how this is working. This is not getting updated in here. It is getting updated, but it's getting updated inside of this. In other words, if tn equals true, the lock equals true, it's going to allow us to increment however many times, and it updates at pretty much every frame or a certain many cycles per time it gets hit. Okay. And because this is being done here and the initial variable is being set from out here, basically what we're doing is we're initializing our variable beforehand, which it starts off at whatever it's at currently. It sets it to it. And then in here, it starts counting it as this loops. All right. Well, it will be and then after it increments, we then set it out here. So we're basically setting it or updating it, setting it to the new number, and then on the next loop it reinitializes in there to the new number, and then it updates inside of the thing, and so it just creates this circular loop where it keeps going back, and it goes and it can increase. All right, that's what we're doing. We're creating this gigantic sort of, it's a little ambiguous, but where it's going out, it's updating this, and then it comes back and it updates, and then it itself, and it just, I hope that makes sense. So this is a way we're getting this to show that this is not, we're not locking. And the problem we have is that if we were creating nodes, that means we would have created 14 basically text nodes inside of this if we had done this. So what we need to do is get a situation where when this updates, that this counter here, this counter is only there so that we can get feedback, so that we have something monitorable that isn't going to be a node that when we hit play isn't going to break Natron because it's constantly trying to build hundreds of nodes every time Natron loops or every time it's done. We want this to be something that one time, once it's done, the initial time this program loads or this node loads, unless some moron like unhides this control and changes it, which is something we don't want them to do. This is why I was showing that hiding stuff. This is going to be hopefully something that we can set once it will update, be hidden, a hidden control, and as long as it's set correctly on export, that it will, when it loads in, it will run one time, the counter will go up once, the code will increase, it will declare a variable or create a node or do whatever you want, and then sort of not do it again. Sounds cool, I hope. This is sort of like doing a script, but we're doing it in a very ambiguous, sort of long-winded way of making this so it's just sort of a cool little, it's weird. And if we run out of this, we may go a little longer into another day. So, all right. So we've created this situation. We've created this counter that goes up. The counter goes up. And we can see it. It does. Now that I'm thinking about it, that loop lock, we really wanted to be very much. We basically want to make it so that if the loop lock goes up, gets changed by 1. Or gets to something set to something else, it never does it again. And you know, the more I'm thinking about it, the more it really doesn't matter, because the variable exists outside, we can, and we're not going to be incrementing it, we can actually set the lock once and it really doesn't matter. So all right, let's see. So tn is this node. Let's change tn to, this is our loop lock. Instead of that, we're going to just call this lock. And if lock equals 0, then we want to lock equals this. I want to make sure I'm doing all instances of lock. There we go. All right. So this is, we've just changed it so that tn, which was originally stood for this node, it's actually going to be our lock. This is going to be a lock. So if the lock is equal to 0, it's going to do whatever's inside of this. If the lock equals anything but 0, it's only going to do it. It's not going to do it. So what we want to do is we want to, inside of here, we want to tell it that the lock is 1. So the next time it loops through, this is going to lock. Basically, we did this in whole counter thing so that we could see something incrementing every time we change things. In fact, it's when, while we've been changing the code in here, it went from 14 all the way up to 20. So every time we change code in here, it would have been creating, if this had been a node, if we had been creating a node, we would have created another 6 nodes in that period of time. Every time we change the text in here, it refreshes. This is why we're not doing a node. This is why we created this counter, so to speak, that is counting every time we do something, is so that we can, as soon as that counter stops counting completely every time we change something or do something silly, then we know we've fixed the problem, we've locked it, and it's not going to update again. And hopefully we can get it so that it always only updates once and will only update one time. Once we can get that counter to only count once no matter what we do, then we can change that count. We can get rid of that counter variable, stick with our loop lock, and replace the counter with basically creating a node, all right, or creating something so that it's locked, so it doesn't. I'm hoping I'm driving this point home, because we're dealing with dangerous crud. This is really dangerous. Can't emphasize that enough. You will crash Natron. I've done it. I did it myself just to test out, will this crash Natron? The answer is yes. All right. But the cool part is if you do a node lock as a counter, we could actually create 20 instances potentially of it, assuming Natron didn't stop, but you could loop it so that it forced it to update anyway. All right. Right. So, right. We're back here. So we did the count. We've got this. we did this. In fact, you know, we might use a loop to counter. We might force a loop so that this counts up. You know what? That's actually a really good idea. No, we're fine. I don't want to take extra time. Sorry, I was getting ahead of myself. All right, so we have it here. We have our lock is calling it. It's getting the lock here. So up here we say that if the lock is equal to 0, it wants to execute this code. Well, the last thing we want to do is after it's executed the code, we want it to actually lock this thing so that the lock won't go any further. So what we're actually going to do here is we're going to grab this node code and change that we've used up here, and just like this counter set here at the end here, we want to hitting too many keys. We want to go here and we want to paste this in, and we're going to set this no, not like that, set, and then we're going to set this to 1. All right, so this, by changing this now, the loop lock, so that it sets it to 1, hopefully, I think that should have done it, right? That's a text string. We've set it, we get it up here, the loop lock set, this node, loop lock set, if lock equals 0, all right, it should work, I hope. Wow, we've already got the counter up to 39. Let's see if this worked. All right, so let's reset this to 0. Boom. We can just drag it back down so that we save ourselves. Let's set this to 0 here. Boom. Notice it updated. The second we set that to 0, the counter stopped, or it updated once, and then the loop lock went to 1. Our feedback went to 1. Let's see this again. Let's see if I put this to 0, it should count to 2. There it goes, it counted to 2. So we've officially, but what we're doing is we're preventing Natron every time we set this loop lock to 0. Whoop, oh, no, it went false. That meant that we got something that wasn't right. It said 0, it was set to 1. We get our output updates correctly, and we can see that was why we had the feedback versus you can see feedback returns out, remember, which said it was false. So basically out said, oh, I didn't go through I didn't get it. We know because the feedback gave us a false response. It meant that the thing that we were getting an error. Basically, you know, it meant it fired. Watch this. All right. So if I set this to anything other than the thing, we can see that the counter is not going to work. This is not updating, but we know it ran because out gave us a false reading. Well, why do we know that means it worked? Well, because back here, if we go to our expression, we can see that out is set to false up here, but down here, out is set to the count. Okay. That means that that if it goes through this expression, out will update to the count number and will give us the number of the count, which is right here, and then it will return it, and we know that it fired. But if it returns false, it meant that it never went through this. It never made it through it. It meant that it was locked out. So this program executed, it said we got a false positive, counter did not go up, so we know our node lock right now is locking it. We are only firing at any given time. The counter is only getting incremented once. Okay? We know it. We've locked it. Our lock is successfully functioning. The only time the lock doesn't function is if we set it to 0, and the second we do that, the counter goes up, and only because we set it to here. And we can see 0, bam. All right. Beat the dead horse. Now that we've got this set, we can create a node. All this just to create one node, one time, when we set that node block to 0. Okay? This is precautions, because I don't want to crash Natron. In fact, just because I don't entirely trust myself to make this, I'm going to hit OK, and we're going to just save this project as And I haven't actually created a project today. I've created a smart nodes thing. We're going to go up here. We're going to go up here. We're going to create a new episode. I don't even know what the episode is. I think this is 85 actually. 0085. All right, and we're gonna call it yeah, it doesn't matter. I'll just leave it at that for right now. It's good. We'll go into the last one. We're gonna say that for the time being, this is just gonna be called dangerous. Danger. Oh yes, and I want to apologize to people who watched the last episode. I have not got it, got the info or the project completely annotated yet. So sorry, it's being delayed. Other things have been going on that have been delaying it. All right. So anyway, so there we go. This is called Dangerous 01. That way, actually, it should be Dangerous Live, but that's all right. We're fine. We know that this is dangerous. Ooh. Might be calling it dangerous. Uh-oh. Okay, good. It's still running. All right. So here we go. Here's a go. We've got our feedback. We've got our counter. We've got everything going. We go into our expression. We edit our expression. The whole point behind this is to make this node, again, completely self-contained, something that is going to create a node. Now, we don't know. One of the things to create a node, we actually have to know what a node's called. We need a name for a node. Well, we don't. It's actually really, believe it or not, it's actually harder to, in my opinion, to actually figure out a node inside of Natron, what all the nodes are inside of Natron than it should be. At least for me, I've had a lot of trouble. There's a way, if you go to command line, there's a command you can type in if you open Natron at the command line. Well, that's dumb. I don't want to open up Natron in the command line and have to type things in to get it. So the best way, this is going to be showing you what, in my opinion, the easiest way of getting a text or figuring out what a node is. A node's name, or what Natron refers to it when it creates it. All right. So we've done too much to this text node over here. I'm gonna actually let's create another color bars. All right. So let's say every time this runs, it's going to create a color bar. So here's a color bars. All right. What we're gonna do here is it doesn't matter where we're gonna do. We're gonna do here. We're gonna actually no, we are gonna use a text node. Do I want to do? I'm gonna think about this. No, we're gonna do it here. We're gonna just say for the color bars, it says minimum, maximum range. It doesn't matter. That's a good spot. Or bar intensity. That's better even. So set an expression here. All right. So what we're gonna do is because I want to get this to feedback in here. We're actually gonna add a text node. Draw text. It's a text node. We're going to make another text node number 4, it turns out. We're going to just go in here. And for text node 4, for the moment, we're going to just drag its output here so we can see it. Whoa. What the heck? Set expression. Whoa, that's weird. We're getting some funkiness here. Oh, crud. All right, cancel. Uh-oh. Multi-line. Oh, boy. And this is one of the things, boy, am I glad we just saved. Well, as we can see, Natron did not like that. I don't know why it didn't like that. Well, that's no good. Thanks a lot, Natron. Oh, I think we crashed it. All right, we're going to have to... Oh, boy. I've really... Uh-oh. Wow, I've really crashed it. My system isn't even responding. Oh, boy. I hope I haven't crashed my stream. Uh-oh. I'm worried I've crashed my stream. No, the stream's still going according to this. All right. We're going to have to... I'll need to stop this really badly. Uh-oh. We need to pull this up. I need to force Natron to stop not responding. I'm going to end that task. There we go. We had to kill it. Sorry about that, Natron, we made a bad maneuver. I'm going to minimize that. Sorry about that. We'll relaunch this and get that going. So, right. Be careful what you're doing. We're doing dangerous stuff. Dangerous. So, for the purpose of this, I think it's because I was getting the text. It might have been because I was... I don't know why. I really don't know. I can't tell you exactly why that particular thing did what it just did. But this is one of the other reasons that I, in many ways, like using a text node. What I really should have done. Oh boy, it doesn't matter. I don't know if it's gonna. All right, yeah, it didn't accept it. We're gonna just open that. Dangerous. There we go. Hopefully dangerous didn't save with that. Yep, it didn't save it. All right, so here's our text 4. All right, what we're gonna do, we're just gonna have it make a new text node instead, just to show. I can show you. All right, we're gonna so we're gonna set an expression here. We're gonna go say this group, or no, this node. If you ever want to know what a node's ID is, we're going to just say this node that underscore or dot get, and then says node, and then it's capital ID, and then you have put 2 parentheses. I believe it is. Uh-oh. Thought that's what it was. Maybe it was just get ID? Oh no, it's plugin ID. Plug in ID. There we go. This node get plugin ID. And what does that do? It gives us this stuff here. Excuse me. What this is, right down here, you can see that it's given us this result. It says this is actually the name of what a text node is. If you ever want to create a text node, you would need this information. So if I take this, all right, and I just want to and copy it, we're going to just hit here like that. I can then go over here and I can tell it inside of this. I'm just trying to think. Well, let's edit this expression. All right, we're going to go back in here. And before we do this, let's go back over to our, okay, this is already set. We have it set, so it's not going to make 1 by default. It's already set to 1. So we don't have to worry about it. It's false tells us we're not going to make something. So instead of this instead of this being here, we're going to change this. Actually, what we're going to do is let me just see. We're going to right here. We're going to say this app, because I like thinking of it as app as opposed to group. Now we could use group, but I wanted to this app, and then we're going to do create node. All right, and then we need to give it the type of node. Oh, it didn't. Why didn't it get it? All right. What was it? Oh, foo. That means that all right, we need to grab it off of that node. So let's grab text 4. Let's pull up text 4 here. This is the beauty of using a text node. Again, makes it easy. We're going to just copy that. And then we're going to paste that right here. Why is that not? Oh, because I'm copying, not. Copy that. Go over here. Control paste, get my keys right, there we go. So we're going to create that, and I believe, trying to remember if there's anything else we need to do. This is why it would be useful if I had just done a silly little I'm going to create a new instance and quickly I'm off screen. I'm just letting you know. I'm going to look up the documentation on this, and then I'll pull it over onto the screen so you all can see this. So, Natron create. Natrons create node. All right, I think, let me make sure I've got the right info here before I go putting this over here for you guys. createNode, there we go. All right, so all right, actually let me step back for a minute. Let me put this on the main screen so you guys can all see this. So I'm gonna just go here. Let's go over here like this. And oh, this is for right now. Let's just because I don't want this accidentally doing something in the background that it shouldn't be, we're hashtagging it. All right, so now we're going to, oh, this isn't actually in the right location. Let's go LBS capture, there we go, and let me grab this, there we go. All right, so here we are. So this is the Natron documentation for app. All right, and these are all the commands that app has. All right, and now I said that it was a GUI app, but one of the things you'll notice that it says here that app is inherited, app inherits group. We already said this, and it is inherited by a GUI app. All right, so group is the lowest level thing. An app, which is what basically our Natron projects are, inherits a group. Okay, so that means an app is a group. Okay, and then a GUI app is both an app and a group. So that means a GUI app has all the functions of an application, of a group, and of its own thing. Just so we can all see what that means. It means it can also do all this. All right. So this is GUI app. It has all this. It has a GUI app, which is what this node or this group. It has this, and it also has all of this. All right. So it can do all of these commands. We can call them all from inside a GUI app. All right, which is what this group is, as long as it is another thing. And one of the things it says is createNode. So if we click here on this, the definition of createNode comes down here and it puts it up at the top. And it says we need a plugin ID, which is a string. Well, we just did that. That's what that little thing was. And then we need a majorVersion, which is an int. It says if majorVersion negative. If it says if you use -1. Then it will use the highest version. Well, you can, this is in case you want to use all versions of whatever. -1 uses the most recent. So we're gonna, that's the thing we were missing. The rest of the stuff is if you wanted to put this in a group, and if you wanted to give it other, stuff. We're not going to worry about anything else for right now. So that's the thing, that's what we're missing. So let's go over to our text one here and go in here. Oops, no, not text one, excuse me, group 2 here. Let's edit our expression and go down here, and we need to do a comma after that, and we want to put in -1. All right, so those are the only two parameters we need to actually create a node according to the documentation. All right, the other ones were optional. Okay, so we've given it, yes, and we need to make sure that's actually a string, not a, we need to give it, put that in quotes, or doesn't, you can use double or single quotes. We'll use single quotes this time, just because, why not? So there we go, single quotes, there we go, it says it, and so that's what it's going to do. But it's only going to do it one time when we set this new loop lock. Oh, well, first of all, we need to set the counter to 0. Let's set our counter to 0. It's never going to count up until we turn that lock off. Now, if everything worked correctly, what we're going to see over here is when we change this loop lock to 0, we're going to create a text node, a new text node. Ready? 0, hit return, click off of this, bam! We just created a brand new text node using a node. That's pretty darn cool. That is really, really, excuse me, we used a group node to create it. That means we could make a group node that creates a node inside of Natron, inside of our current project. It has complete control over our application. Not only that, but we could use that the same process to delete a node. All right. So this is really exciting, really cool stuff. Very complex, very, very, very dangerous. Because if we didn't have that lock, if we didn't create this lock setup here, and by the way, this counter thing, we were only using that to give us a variable. This is not actually needed. But once we're done with this, if we don't want this to be something that users create and can modify in the future, what we would do is we need to actually, wait a minute, I'm thinking about this. Yeah, we don't need the counter. The counter was only there so that we could make sure that we weren't constantly counting. This was just an intermediate until we were ensuring that we weren't randomly going to do this. In fact, let's verify. If I set this back to 0 again, ready? We're going to create another new node. Boom! There we go. thisNode 3. That's pretty cool. I can create as many of these suckers as we want by just setting this to, you know, and look at that. It automatically named it, and you'll notice it skipped thisNode 4. So what we're seeing here, this is fantastic for me. It means you could, in theory, create an entire Natron program inside of a node, inside of a group node, have it constructed so that you could create a preset that loads in a group node, a plugin, not a script, a plugin that loads in an entire node graph as if for yourself, just like it was, you know, just like a thing. But instead of loading it inside of the plugin, it would load it inside, or would create it inside of the group. And you could rig it up, and you could do all kinds of stuff. You could delete nodes, you could create new nodes, you could do. There's just so much potential power in this, and there's even more we could do. For example, we're not going to do this because we're running, you know, pretty long today. But what this really means, what we can do, we can also create like instances. We can control all of the GUI layout because this is a GUI node. The GUI is the interface. That means we have access to opening up color panels, color dialogues. We can open up all the dialogues, gain access to them, and have the user enter, you know, do data entry in it. And then dynamically, so when you load it, it can pull up something that just says, you know, here's a dialogue that opens up when this loads. It automatically, this group loads. I could have it pop up a color. It says, I need a color in order to continue. Why is that important? Well, what if I need a color? I need the user, in order to give the user, in order to continue, I have to have a color of some form. Well, that means that you need to a specific, you know, something other than white, or something other, some user-defined property. You want to force the user to always, you know, enter it before that program builds that color node for the user. Well, you could make it so that the group node loads in, creates a custom node with all the colors that the user defines on load, and then it deletes itself in the process. You can actually, I can make this group node, after it's done creating the content of this, delete itself so that it doesn't exist, so that there's no need. It's done what it needed to do. It's created it. It also can set up, but the other thing that's kind of cool is, for people who, I believe it can do this. We're splitting this. I just split our layout here so that I can put in the script editor here, because I also want to pull up. I believe we have. If I sit here and say this app, I just want to see. Or let's print this app, because this app is not actually a scriptable thing by default. But we've loaded up this project. It has it defined in one of these nodes. So the question I have is print parenthesis this app. All right. So this is in scripts. This is a script thing. When we hit, let's clear this script so that we can see what happens here. So what I'm going to do is see if I can print this variable called this app. Well, this app has not been defined at the script level. It's been defined at a node, but I believe that the node, because the GuiApp is controlling it, we've defined this app again as this is the thing. This is what we're controlling. We're controlling this app. So if I say print this app, I should, I'm hoping, get the actual application instance. And indeed, from our script editor, because it exists in this node and it's being defined in this node, and we've defined it, the script editor also is noticing this. So this means if we can somehow make it so that there's a preloaded script at the beginning of our project that loads this in and loads up our stuff, or loads a node and then destroys it. Now, understand something here. You can do a lot of stuff with scripts, but I really don't like scripts. And there's a big reason I don't like scripts. The big problem I have with scripts in Natron is that if a script is broken or breaks, and it loads into Natron by default, and it modifies Natron in a bad way, you can end up with Natron not functioning properly. So I don't really like using scripts. I recommend people downloading the custom plugins and so forth. And oh my goodness, we're at an hour and a half or just over. This is going on long enough. But the whole point is this is just really cool. I wanted to share this, show y'all this is exciting stuff. Exciting stuff, really powerful, very dangerous stuff that you can do inside of Natron. And I'll tell you what, I don't think there's another VFX program out there that would let you do this level of control, because we're literally talking application level. I can literally close this instance of Natron from inside of this node. I can also launch a new version of or another instance of Natron from inside a node. That's crazy. I can also copy stuff from this instance of Natron to another instance of Natron, sort of. I don't know the exact routine, but I could, in theory, copy it to the clipboard, have something in the other Natron, copy it, paste it into that one. You could just do all kinds of things. But as we can see, even if you do loops, it will limit itself to so many cycles before it stops, unless you do something stupid like hit play. Which, anyway, I've way rambled on way longer. Thanks for watching. Keep on Natroning.